In today's class, we will discuss Chapter 3, Understanding Quadrilaterals. Hello everyone, I am Payel and welcome back to my channel, Ganit Mathematics Classes. See, before starting this chapter, we will discuss some basic concepts for this chapter. So, the first one is plane curve. Now, what is plane curve? If we draw anything in the plain paper without lifting our pen or pencil, that will become a plane curve. So, this is a plane curve. Some more examples of plane curve are like this. See, we have drawn here a triangle by using only line segment. This is also a plane curve. And then if we draw suppose a line segment and then the curved lines and then we have joined it, this is also a plane curve. Just without lifting our pencil, we have to draw something that will become a plane curve. Next, come to closed curve. So before discussing closed curve, let us have some concept of open curve. What is open curve? See, this type of curves which are open, whose starting point and ending point are not same. Those figures are called open curve. See here, open like gate structure is there. From here we can enter or go outside of the figure. So these are called open figure. Now what is closed figure? See, where the figures where the starting point and ending point is same. Suppose if we draw something like a circle, we have started from here and then and here only. See here, there is no opening. The whole figure is closed. So this kind of figures are called closed curve. Similarly, if we draw like this is also a closed curve. Okay. Now come to simple closed curve. Now it should be a closed curve, and simple means what? It should be made up of only line segment or only curved lines. See, only line segment we can draw a quadrilateral. So this is a simple closed curve. Or we can draw a circle. This is also simple closed curve. See, this circle is made up of only curved line and it is closed curve. And this quadrilateral is made up of only line segment and it is a closed curve. So both the figures are simple closed curve. Hope you have understood this. Now come to the next point, that is polygon, which is main topic of this chapter. A simple closed curve made up of only line segments is called a polygon. It should be a simple closed curve that just we have discussed, and it should be made up of only line segment. No curved line is allowed here. So this kind of figures are called polygon. Okay. See here, I have given some examples of polygons. Say first one is a triangle. We all know it. It has 3 vertices. Now see, according to the number of vertices, the name differs. So it has 3 vertices, so it is called a triangle. Next one is a quadrilateral. Why it is quadrilateral? Because it has 4 vertices or 4 corners, so this is called quadrilateral. Similarly, for 5 vertices, it is called pentagon. For 6 vertices, it is called hexagon. And for 7 vertices, it is heptagon. And for 8 vertices, it is octagon. Okay. So you have to remember the names. Next is consecutive and non-consecutive vertices. See, if we draw a quadrilateral here and name it A, B, C, D. Now first is consecutive vertices. So first of all, what is vertex? The corner points are called vertex. Okay. So the vertex of this figure is A, B, C and D. Now come to what is consecutive vertices. Consecutive, the word means that it is continuous. Between 2 point or 2 number, there should be no difference. Okay. So say A, after A it is B. So these are continuous vertices. So A and B is consecutive vertices. Now B, C, these are also continuous, B and C. Okay. Now come to non-consecutive vertices. So non-consecutive means what? Between 2 vertices there should be another vertex or another number of vertices. Okay. See, between A and C, if we consider these 2 vertices, from this side if we consider between A and C, the vertex D is there. Okay. Similarly here, between A and C, the vertex D is there. So that's why A and C are non-consecutive vertices. Similarly, one more example will be B and D. So see, between B and D, from this side C is there and from the other side A is there. So B and D is non-consecutive vertices. Okay. Next come to diagonals. What is diagonals? Just simple only. If we join the non-consecutive vertices with a line segment, that will become a diagonal for a polygon. Okay, first we will discuss for the square, then we will come to the triangle. Okay, first name it, let us name it P, Q, R, S. So here the non-consecutive vertices are P and R and Q and S. Yes, so we will join them. So let us join P and R. P and R. So this is a diagonal for the square. Another diagonal will be if we join the vertex S and Q. So this is the another diagonal for this figure. Okay. Now come to this triangle. Say ABC. See, in this triangle, first you have to find the non-consecutive vertices A and B. A and B, see, these are consecutive. B and C, this is also consecutive. A and C, this is also consecutive. So there is no non-consecutive vertices in a triangle. So that's why we can't draw any diagonal for a triangle. Okay. Next come to this pentagon. And let's name it A, B, C, D, E. Now we will join the non-consecutive vertices. First, see, let us consider A. A and B are consecutive, so we can't join, or we can say it is already joined. How can we join again? Okay, next is A and C. So A and C, between A and C, B is there, so they are non-consecutive and we have joined it. Similarly, A and D are also non-consecutive, so we will join it. Now A and E, these are consecutive vertices. Next come to B. B and D. B and D, these are non-consecutive vertices, so we will join them again. B and E. So we have got the diagonals. Now C. C and A are non-consecutive and it is already joined. Now come to C and E. So we will join the C and E. Now come to the point D. D and A are already joined and DB is already joined. So these are the diagonals for this figure pentagon. Okay. Hope you have understood this. The next is convex and concave polygons, most important topic of this chapter. What is convex polygon? A polygon in which all the angles are less than 180 degree. All the angles should be less than 180 degree is called a convex polygon. And another definition is that polygon that are convex have no portion of their diagonals in their exterior. So I will discuss this after some time. First, let us focus on the first line. A polygon in which all the angles are less than 180 degree. First, let us consider this triangle. We know that in a triangle, all the angles are less than 180 degree. Yes. So this is 90 degree. From the figure only we can say. And these two angles are obviously less than 90 degree. And if it is less than 90 degree, then obviously it should be less than 180 degree. So this is a convex polygon. Okay. Now come to this figure. And this is an octagon. And easily by watching it, we can say that all the angles are less than 180 degree. Now, you may ask how. So, let me explain. See, we will discuss about this angle. Okay, all the angles are same only. We will discuss about this angle. Just extend this angle. We have extended this angle. Yes. Now, see, this extended line. This extended line, that means this is a straight line. Okay, what is how to draw 180 degree angle? So if a straight line you draw, then it will become an angle of 180 degree. Okay. Similarly here it is 180 degree. Okay. Including the extended portion. Now see, our angle in the given figure is up to this much only. See, this portion is obviously less than the 180 degree angle. Yes. So that's why here this angle is less than 180 degree, and similarly you can check all the angles are less than 180 degree. Okay. Similarly in the pentagon also all the angles are less than 180 degree. Okay. So that's why these polygons are convex polygon. Now come to the concave polygon. A polygon in which one angle is more than 180 degree. Any one angle should be more than 180 degree in a concave polygon. So those kind of polygons are called concave. And the second one is polygon that are concave have their diagonals in their exterior. Okay, we will come to this point now only. Just discuss this. See, this is a figure, a star-like figure. So see, this inner angles are obviously less than 180 degrees. Simply we can say that. Now come to this angle. Okay, now let us discuss about this angle. We have to just draw a straight line over there. So let us extend it. This is the extended line. Okay. Now this is the straight line and it is 180 degree. Yes. Now say our given angle is whatever is there in our figure. This is this whole angle. See, now this portion is more than this 180 degree angle. Yes. So that's why the star or this particular angle is more than 180 degree. And we need only one angle which is more than 180 degree, then the figure will become a concave polygon. So similarly, this is a concave polygon. Now come to this simple figure. Here see, if we consider this angle, it is more than 180 degrees. How to check? Just extend this line. Okay. And then see, up to here it is 180 degree and this portion is more than 180 degree. So that's why this particular angle is more than 180 degree and hence it is a concave polygon. Okay. Now next part is that, or another definition of a concave polygon is that we can draw a diagonal in their exterior. See, this is the interior of this figure. Now which is the exterior? Outside of the figure, it is called exterior of the figure, and it is said that a diagonal we can draw in the exterior of the figure. See, this is a vertex and here it is vertex. So here easily we can draw a diagonal. Okay, this is a diagonal for this figure. So this is another definition of a concave polygon. If we can draw a diagonal outside of the figure of any polygon, so that polygon will be called a concave polygon. Similarly, in this star also say this vertices you can join easily, or you can draw the diagonals outside the figure. So this is also a concave polygon. Now come to this convex polygons. See, convex polygons, the outer vertices are already joined. We can't make any diagonals outside the figure. Obviously inside the figure we can draw many diagonals, but outside the figure we can't. So that's why it is called a convex polygon. Now one trick to remember concave polygon is that, see, in the word concave, a cave word is there. This is a cave word. Okay. Now see, in this figure, a cave-like structure is there. Yes, this is like a cave. So this is a concave polygon. In this way also you can remember, and in this figure also see here a cave-like structure is there. Okay, so this is also a concave polygon. This is a trick to remember what is convex polygon and what is concave polygon. Hope you have understood this. Now come to regular and irregular polygon. This is very simple. Regular means what? It should be equiangular and equilateral. Now what is the meaning of equiangular? Equiangular means all the angles should be equal. See, it is a square, and in a square all the angles are equals to 90 degree. So all the angles are equal. And equilateral means what? All the sides should be equal. So in a square all the sides are equal obviously. Now it is the octagon. In octagon it is a regular octagon. Okay, regular octagon means what? All the angles are equal and all the sides are also equal. This is called a regular polygon. Now come to irregular polygon, a polygon which is not equiangular or neither equiangular nor equilateral is called a irregular polygon. Now if you consider this triangle, see, it is 90 degree, this angle, and other two angles are less than 90 degrees, so it will be a irregular polygon, and all the sides are also not equal, so it is a irregular polygon. Similarly, in this quadrilateral, all the angles are not equal, even all the sides are also not equal, so this is a irregular polygon. Okay. Now come to angle sum property. This we have learned in our earlier class, that angle sum property of a triangle. What it says? The angle sum property of a triangle, that all the sum of the angles of a triangle is equals to 180 degree. That means measurement of angle A plus measurement of angle B plus measurement of angle C is equals to 180 degree. Sum of all the angles of a triangle is equals to 180 degree. Now this is the angle sum property of a quadrilateral. Okay. So it says that sum of all the angles of a quadrilateral is equals to 360 degree. Okay, let us discuss it how. So here is the quadrilateral PQRS, and we will divide this quadrilateral into two halves or two triangles by drawing a diagonal over here. Okay, so this diagonal has divided this quadrilateral into two triangles. The first triangle is PQR and another one is PRS. Okay, so now we will show how sum of all the angles of a quadrilateral is equals to 360 degree. Now first we will consider triangle PQR. In triangle PQR, see, angle PQR plus angle QRP plus angle RPQ is equals to 180 degree. Equation number 1. Now from this triangle PRS, angle PRS plus angle RSP plus angle SPR is equals to 180 degree. As sum of all the angles of a triangle is equals to 180 degree, just we have applied that. Okay, now we will add these two equations, equation 1 plus equation 2. First we will write down all the angles. Okay, so the first one is angle PQR plus QRP plus RPQ plus PRS plus RSP plus SPR equals to 180 degree plus 180 degree, which is equals to 360 degree. Okay, now we will rearrange the angles. Now see, PQR, this is the whole angle, so we will just write it down, PQR plus. Now next one is QRP. First we will write, then we will see QRP, this half angle. Okay, with this if we add this angle, then we will get the whole angle QRS. So which angle we have to add with this? PRS. See, PRS is there or not? Yes, PRS. So we will write them together, angle PRS, and we will put them in a bracket. Okay, next is angle RPQ. Now see, RPQ, this angle. Now with this angle, if we add this portion, we will get the whole angle. So which angle we have to add? RPS. RPS is there or not? RPS or SPR, same angle only. Okay, SPR is there, so we will write them together, SPR. Now put it in a bracket. Okay, next we are left with angle RSP plus angle RSP equals to 360 degree. Okay, now this implies angle PQR plus QRP plus PRS. QRP PRS is angle, this whole angle QRS, angle QRS plus RPQ SPR. If we add them, we will get this whole angle. So we can write it as SPQ, angle SPQ plus RSP equals to 360 degree. Now you can see that the sum of all the angles of a quadrilateral is equals to 360 degree. How? PQR, this angle, PQR, this angle, QRS is this angle, then SPQ, this angle, and RSP, this angle. So we have got all the angles, and sum of all the angles is equals to 360 degree. Okay, So here we have proved that the angle sum property of the quadrilateral. Okay. So for today we will end our class here only. In our next class we will discuss exercise 3.1 thoroughly. So if you are new to my channel, please do subscribe to my channel and hit the bell icon to get all the notifications. Thank you.